The letters USGS and words Science for a Changing World appear in white, then fade to black.
The following presentation content is from a webinar co-hosted by the USGS and the National Fish Habitat Partnership on October 8, 2024. The presenters are Karen Adkins, User Engagement Hydrography Focus Area Lead, Steve Aichele, the National Geospatial Program Planning and Management Lead, Silvia Terziotti, the National Geospatial Program Hydrography Science and Applications Lead, Kim Jones, the National Watershed Boundary Dataset Team Lead, and Sue Buto, the 3D Hydrography Program Data Acquisition Lead. So in our overview, I will start off with talking about the National Geospatial Program and the national map. So as many of you may know, the U.S. Geological Survey is a part of the Department of the Interior. We are a bureau within the Department of the Interior, and we work alongside many other bureaus like the National Park Service. Next slide. And the USGS has 5 mission areas that are listed at the right. The mission area that our geospatial data programs are housed under is in core science systems, and it focuses on conducting research, gathering information, providing technical expertise, building and facilitating partnerships, creating new geospatially enabled data, and providing a framework for that data to be shared. Next. And the National Geospatial Program is a program within core science systems, and the NGP mission is to provide topographic information for the nation. This helps to advance science, support government, enlighten citizens, and enable decision-making. And NGP works to increase the efficiency of the nation's geospatial community by improving communications about geospatial data, products, services, projects, needs, standards, and best practices. Next. And the NGP accomplishes the mission through a broad portfolio. Here are just a few examples. I'm not going to go into most of these today, but you will be hearing about the 3D Hydrography Program, of course, and I will be talking first about the national map. Next. The national map is our suite of authoritative geospatial data and services. We provide free of charge and without use restrictions. It is a collaborative effort among USGS and other federal, state, and local partners to improve and deliver topographic information for the nation. And you see here that the topographic data and map products and a range of related applications and map services is really a core of the national map. Of course, have our topographic maps and services. Many are familiar with the topographic map products. So have our geospatial data. We have foundational data such as elevation, hydrography, geographic names. That is really the authoritative source for these products. Curated, which comes from a combination of other sources that we use to help build our national map. Structures, transportation, and boundaries, and then contextual information such as land, cover, and orthoimagery. Again, it's public domain data available free of charge, and we do build our data based on partnerships. We do have resources that are focused on working with partners to build and maintain that data. Next. Of course, and there will be a couple of clicks here. So next, so our most familiar products are the topographic maps. Many people are familiar with these products and use these products for a variety of purposes. We have historical maps that are scanned maps from 1884 to 2006. Our US Topo is the most current map series published as digital documents. And then now we have Topo Builder, where you can create your own custom maps on demand using the USGS Topo Builder application. Go ahead and hit next. You can take multiple maps within the application. Next. Select an area. Next. And it will generate your own custom bounding area and create your own custom map. And you can further customize the map by choosing the format, area of interest, and even the content that goes into that map. Next. And topographic data is a big part of the national map. Elevation is also a very popular product. The 3D elevation program provides multiple 3D LiDAR products. We have high resolution standard DEMs that are available in 1 meter in CONUS and 5 meters in Alaska. We have LiDAR point clouds that are collected under the 3D elevation program. Specifications for quality level 2, nominal point spacing and vertical accuracy. And of interest to the community here today, LiDAR can be used for evaluating many areas on the landscape. You can determine stream shading. You can use the LiDAR as a variable for habitat modeling and much more. Next. Many of you are also familiar with the USGS National Hydrography products. These products aid in mapping and analysis of water and water management issues related to where fish live, migrate, and the habitats that support them. These products will no longer be updated under the 3D Hydrography program, but will continue to be available as static data sets. Next. Hydrography program, next, is providing new data in a new model, many benefits of the legacy data sets, and some new ones like Z values. This data is currently available as a web map service, and you will learn much more about the data and future plans in the next presentations. Next slide. We also have the Geographic Names Information Systems. This is the database of the USGS, or the U.S. Board on Geographic Names, or BGN. Supports the decisions of that board and allows us to apply names that are managed by the board to our data and our maps. And this gives the community the place to go for information that provides place-based references. And you can find more information through the database on the public search page, and you can also download GNIS data at the link shown here. Next slide. We also have support theme data. These are the boundaries, transportation, structures, imagery, and land cover. This is these support themes are not designated for us to manage, but we have a vested interest in the consistency, accuracy, and completeness of the data for use on our cartographic products and services. And these data are a part of the foundation for representing topography, natural landscape, and man-made environment. But for the most part, I'm not going to go into detail about these, but I can certainly provide more information in a future meeting if needed. Next. One item that I did want to highlight is that may be of interest to this community is our National Trails project. This uses the National Transportation Database, and this may be of interest to the community because trails and trails planning can introduce a factor in studying and protecting fish habitats and waters. There is a tool that is used for planning. It is not a publicly available tool. So if you're interested in learning more about the application and the management of this data, It does come from various states and organizations that we are compiling into a national database. You can contact the email trails@usgs.gov to get more information on this. Next slide. And of course, access. We have many different ways to access our data. You can access directly through cloud links. We have a downloader application that you can access data from. You can select the type of data that you need and download it. To find more about the data delivery, go to the link USGS.gov, National Map Data. We also have a landing page that gives you access to our applications, not only to download and view the data, but also to interact with the data. We have some great visualization services, in particular for LiDAR. So check that out at apps.nationalmap.gov. Next slide. And I had mentioned partnerships. We have national map liaisons that service every state. They work with the states, tribes, local governments, and other organizations and data users. We interact with people on a daily basis. You will find national map liaisons at a number of events and conferences, presenting and performing outreach to inform our users about our data products and services, and to help you understand them, use them, and provide feedback to the program so that we can continually improve our data. We also work with the states on partnerships to build our data through the 3D National Topography Model for 3DEP and for 3DHP. So if you have questions, please reach out to your local liaison. They are there to help you. And you can find us at usgs.gov at user engagement. Okay. That's all I have, so I will turn it over to Steve Aichele.
All right, next slide, Alexander. Okay, so my name is Steve Aichele. As Karen mentioned earlier, I'm the management planning lead for the 3D Hydrography Program. I'm trying to keep everything coordinated and moving together. And I have the next dozen or so slides here. If you zone out for the rest of the slides, this is the slide to remember. This is what we're doing here. We are replacing all of the old hydrography data that has existed before with new data. We're going to put it in a new database that'll be easier to use, easier for us to maintain, easier for you to use, and we're going to deliver new products. So a different suite of products than we have delivered in the past. As Karen mentioned, we're going to keep the old products available in a static form, but we are redesigning entirely how we do hydrography in the country. And again, it starts with really the first systematic recollect of the hydrography data since the middle part of the last century, when we were sending survey crews out to collect the stuff. Next slide, please. Okay, so this is a little bit about where we were, the previous approach, right? Many of you were familiar with the NHD on the survey earlier. Many of you were familiar with the NHD Plus in its various flavors. And that data set was great. It was based primarily off of the blue lines from the old 1 to 24,000 topographic maps, and collectively represented over 9 million miles of stream network, 8 million water bodies, 130,000 nested hydrologic units within the WBD. And this data was maintained through a variety of partnerships with state, local, federal agencies over the years. Eventually, at some point in time, 41 different states and Washington, D.C. all participated in updating the data. Unfortunately, those updates were not really very uniform. Particular states would have an initiative to do a particular hydrologic unit or a particular county, or some of you probably worked around, around the state of Indiana. State of Indiana did a really, robust job on mapping within the state, but at the state edges, streams disappear, which is not particularly useful for many analysis purposes. National consistency decreased, both in terms of that sort of stream density and precision of the features that were collected, but also just which features were collected. The NHD data set had evolved over time to include a little bit of everything, right? We had 22 different flavors of pipelines. We had roughly similar number of canal feature types. We had swimming pools in there. Swimming pools were only populated in a few places. And so taking this data set and doing useful multi-jurisdiction analysis with it was difficult because you never really knew what you were getting, and if you were getting an exhaustive, a complete inventory of whatever it was we thought was in the data set. And then finally, the fundamental issue of moving from that field survey environment where people are out there collecting a few points with rods and theodolites and plane tables to the LiDAR world we're in. A lot of that older data just doesn't align very well with the new 3DEP data. So new slide, please. Okay, so why modernize? As we actually got a sense from the survey earlier, there's a lot of utility in these data sets. Getting a little long in the tooth now, but 8 years ago, we worked with Dewberry to do the hydrography requirements and benefits study. And back then, pre-inflation and everything else, we identified there's potential for $1.14 billion in annual benefits if we could meet the user requirements that were identified back then. Since then, I suspect both of those numbers have increased, but really there's a substantial benefit to be realized by improving the quality of the hydrography data we have. Next slide, please. And this is the picture's worth 1,000 words slide, or actually one of them. And I won't give you 1,000 words, but over on the left is our 3DEP status map. So as you can see, it's almost all green now. We have better than 98% of the country either acquired and published or in work. And on the right, you see an example from the state of Washington where they did a pilot project. The green lines shown there are the existing NHD data. The gray, obviously, is a hillshade of the DEM from 3DEP. And the blue lines are the elevation-derived hydrography that was created from that DEM. Now, for those of us that are old enough to have gone out, before GPS, right? If you went out and sampled something in the field, somewhere in the middle of that picture, you'd probably attach it to the green line and, call it good enough. Like, yeah, that's probably right. But nowadays, when everybody has a GPS in their pocket, GPS in your pocket, that's the point you're sampling isn't necessarily on that green line. And that level of precision starts to matter. The other thing is, as many of you have probably realized, if you try to do a longitudinal profile along that channel using the new elevation data, you get something approximating gibberish, right? So these are a couple of the sort of basic problems we're trying to address here. Next slide, please. Okay, so basic program goals. First and foremost is really align vertically, horizontally, and temporally with the 3D elevation program data and replace all of that older hydrography data that's been out there with new data derived from the 3DEP LiDAR and IFSAR in Alaska. One of the advantages of following 3DEP, in addition to having all this fabulous elevation data to work with, I apologize, an old status graphic on there. But one of the advantages of following the 3DEP program is that we get to learn from some of the things that they did. Actually, the first thing we learned was to do that requirements and benefits study. 3DEP did a requirements and benefits study called the National Enhanced Elevation Assessment before launching their program to identify what the program requirements needed to be and what the benefits would be. So we did that and worked through some of the best practices that have been developed for the 3DEP program, including things like, shared data governance, working through a data collaboration announcement, which Sue Buto will talk about here in a little bit. Working through our geospatial products and services contracts to acquire data in a structured way, and also working with real firm specifications and data validation, so that from a data management standpoint, we know what's in the database and it behaves in a predictable way when we need to make a change to something. But also from a user standpoint, you know what's in the database and you know what you're getting when you receive data from us, and you can count on it behaving in a predictable way. A couple of the enhancements we're looking to work into the system. Actually, the bold one is the most important one. Is really building this from a hydrologic standpoint rather than a cartographic standpoint. NHD was really capturing the blue lines off the topographic maps and all the hydrography, watery things that would need to be put back onto a topographic map at some point. In this system, we're really moving past that to building things to do things like water balance accounting, do things like ecosystem management, flow modeling, and we will make maps from it. This stuff will eventually be portrayed in maps, but that's a secondary application. Similarly, we want to be able to do better ties to NWI, the National Wetlands Inventory, and eventually increase our interoperability with other data sets, infrastructure, soils, stormwater systems, that sort of thing. Next slide, please. Okay, so we touched on a couple of these examples in the survey earlier. But there's a really long history of hydrography mapping knocking around. And what's maybe more remarkable is that all of these are still in use for something somewhere out there, right? People are still using the old RF1 data from about 1980-ish. A lot of RF3 data out there. NHD Plus version 1 and 2 are still very common. And they all have a little bit different linear referencing system, right? A little bit different system of attaching data values, observations to those lines. One of the things we want to accomplish here in working with OGC and our water mission area and a thing called the Internet of Water Consortium, which I'll talk a little bit more about, is to come up with a common addressing scheme, right? So this is making sure that a feature, the Mississippi River, has the same identifying scheme, the same identifier specifically, in all of those data sets. And so if you take a tissue sample or a water temperature or flow discharge on a river, you can migrate it from any of those data sets into 3DHP. And so this is one of, I think this will be a fairly revolutionary kind of thing when we can pull all this data together into a common referencing scheme. Next slide, please. Okay, so this is not a slide that you need to look at in detail, but I want to give you the impression of what we have been working with. Up on the upper left is the National Hydrography Dataset data model from about 2022. On the right is the Watershed Boundary Dataset data model from about 2022. And then down below is the NHD Plus high-res data model. And collectively, these represent about 250 different feature types, everything from streams and rivers and lakes and ponds to swimming pools and sewage treatment ponds and so forth. There's also a lot of overlap across these and interrelationships, right? So the first few digits of an NHD reach code were tied to the watershed boundary data set. So a change in the watershed boundary data set could drive a change in the NHD reach coding, which gets to be kind of circular. And then both of those end up in the NHD plus high res, where there's there's pieces of the WBD, there's pieces of the NHD, and it's got to be a very complex ecosystem to try to keep these things synchronized and managed. We had about 250,000 lines of code that did that management. Took a little while, but we got it together. Unfortunately, as some of you are probably aware, Esri ended maintenance for the Arc desktop environment, I guess earlier this year, and all that 250,000 lines of code became obsolete. And so we were faced with either really a massive recoding exercise to migrate all that stuff to Arc Pro, or look at it as an opportunity to rationalize what we're doing here a little bit to make this easier for everyone to use and understand. And that's where we got. That's where we went. We're going to consolidate all three of these data sets into one thing and really radically simplify these. Make the catchments that many of you are familiar with from NHD Plus really integral to the system, not something we calculate later down the line. Make those, use those to build the hydrologic units for sort of the successor to WBD, and then really simplify this whole workflow. One of the real challenges of keeping all this stuff synchronized was that as we, as an edit maybe came in from a steward on the NHD, it could be years before that change was reflected in the NHD Plus high res, like 4 or 5 years, which is a long time to wait. We would like to bring that number down dramatically, and this is sort of a driving force behind this whole exercise. Next slide, please. Okay, so this is, again, you don't have to read it in detail, but this is where all of that stuff that was on the last slide ended up. We were able to retain about 95% of the actual features, the streams, the lakes, the canals, but we consolidated those into about 10% of the feature types, which makes it a much easier thing to manage and use. A lot of that was just reducing the repetition across the data sets, so we're not trying to keep things synchronized. And again, we wanted to make sure we were focusing on the hydrologic content of the system, not on how it should be represented on a cartographic product. Next slide, please. Okay. So that talked about a little bit about the data model, the data structures, sort of fundamentally about the data. We have specifications for hydrography, which we had not had for a long time. There were specifications when we collected the data for the original topographic maps 50 odd years ago. And in 1999, we had draft specifications for the NHD at the 100,000 scale. But we never had published specifications for the NHD. They were always in that draft form and sort of evolving ad hoc. In 2020, Silvia Terziotti, who you'll hear from in a minute, along with Christiana Aichele and a number of other folks in our Technical Operations Center, assembled the first specifications for high-res national hydrography. I don't know, a very long time, decades. And the idea here is, again, to make sure that we're collecting data in a consistent, accurate, and precise way. Again, this is an example. I think this is also from Washington, although I should have labeled on the left here. It shows a similar sort of situation, right? This is the purple lines, magenta lines are the existing NHD for the area. The blue lines are the data derived from the LiDAR, and then the LiDAR hillshade obviously in the background. And those of you that are familiar with the NHD Plus, what we were doing to create the NHD Plus high res, at least, was forcing those purple lines into that DEM until the water all flowed to the purple lines. And so we were taking some really fabulous elevation data and making a hash of it to make the water flow across the surface. We are inverting that process here and using the surface to tell us where the water is. And then every once in a while, we have to do a little bit of tweaking to make it flow, but there's a much lighter hand on that data than what we're doing for the NHD plus. I think that's it for the next slide, please. Oh, right, okay. And so this is the other side of having specifications. It's all well and good to say you have specifications, but if you can't prove you're meeting them, then that's kind of academic. So one of the other things that we have implemented is an actual validation workflow, so that all the data that comes in before it ends up in the database, it gets to that green box on the right there, 3DHP ingestion, is checked for several dozen characteristics related to the specifications. And so, I mean, there are things here that we could probably quibble about in detail, but again, the idea here is that we're setting a basic threshold, a standard for what should be in this data set, so that it behaves in a predictable manner, whether you're using it in New York or Indiana or Washington or California. You will see similar things in this data set across the country. And so this is something that, again, had not existed since we did the original editing for the 24K topo maps, right, back in the day. Because the NHD was based on those topographic maps and we had a stewardship activity, we always sort of assumed that whatever came in from the stewards was better than what we had in the NHD because somebody had spent the time to invest in it. And generally that was true. We got a lot of good data from the stewardship activity. But we never checked it for consistency, never checked it against another source, elevation data, orthoimagery. It was always a matter of just sort of trust, and usually worked out well, sometimes didn't. And actually, sometimes when it didn't, caused some challenges. So one of the ideas here is to really lock down what gets into the database so that it is a consistent product that people can have expectations about. Next slide, please. Okay, so these next two are just more graphics. This is an example from a little bit north of where I sit in Harrisburg. This is from central Pennsylvania, showing some sample data for the Kitchikokwillis Valley. The purple lines here are the NHD existing, and next slide will overlay the new blue data. Thank you. For the elevation-derived hydrography, just showing both better fidelity, again, to the elevation data, but also much more detail, particularly in headwater environments. And so we think this is a significant improvement in a variety of ways. Next slide, please. Okay. And so making data is great. Like, hey, that's all very cool and techy and whatever, but it doesn't really matter until somebody actually uses it for applications. And this is what's these mission critical activities that were identified in the hydrography requirements and benefits study are really what's driving this program. We want to be able to provide better data for flood modeling, very timely at the moment. We want to be able to provide better data for river and stream flow management. We're going to be able to provide better data to NRCS and the agricultural community for farm management. These are all things that are supported by hydrography data and have dollar benefits associated with them that are going to be better done with data that actually matches reality rather than rather than what was surveyed 50 years ago. Next slide, please. Okay, this is a little bit of a shift, but now we're going to talk just a couple slides about getting the data. And one of the changes here, many of you used the NHD and the NHD Plus, have downloaded data and used it. Actually, many of you have downloaded data tweaked a few things, and then used that copy as a branch, right? We want to try to move to a world where, one, we're providing really authoritative data through a web service, and where people are using that web service primarily for their day-to-day activities. And so this gives us the opportunity to make that latest data available, but also gives also limits sort of that branching and orphaning problem that many organizations have had over the years. In the downloaded world, we will have an annual static release. This was particularly important to the academic community. They wanted something that they could reference for research purposes and say, you know, I used this version of the product that you can go get and recreate this analysis. That was not something that was readily done with the NHD world, but that's something we are trying to support now, again, through these annual static releases. And again, that frequency could change. Right now, annual seems to be sort of where things have settled. Next slide, please. Okay. And then this is a different concept. And this is the idea of the Internet of Water. I probably should have had Alexander throw up a question about how many of you have heard of the Internet of Water. But in very short form, probably all of us on this slide are collecting water data in some form or another. Certainly the USGS has lots of it, EPA has lots of it, state agencies have a lot of it. But also a lot of it sits on spreadsheets or access databases or some other place where it's hard to get at. What we're trying to create, the USGS and our federal partners are trying to create a federated data discovery system so that if you go out and collect sample data, that one, there's an easy way to address that to the network, but two, there's an easy way to make that data discoverable to other people that might want to use it for something. And this is all supported by a thing called the Internet of Water Consortium and a technology known as GeoConnects, which we can talk about later if people are interested, or we can move on to the next slide. There we go. And so this is just a couple slides sort of showing what's going on there. This happens to be the Yellow Breeches Creek, which runs past my office here. It's a world-class trout stream, that sort of thing. And every feature has a main stem ID. And this is the OGC standard identifier, and this is the identifier that crosses data sets. Next slide, please. Okay. So what I've shown here, and it's a little smaller, I apologize, is that GeoConnects ID. And so this points to a landing page, which we'll show on the next slide, that identifies a variety of relationships between the Yellow Breeches Creek and upstream, downstream connections, watersheds, that sort of thing. So go ahead and hit that next slide, Alexander. Okay, so they're over there on the right. When we've started to populate some of these, you can see there's a NAHD plus version 1 COM ID link there. There's a version 2 COM ID link there. We know what HUC 12 the Yellow Breeches Creek is in. We know what the headwater RF1 ID is. So this is the sort of the breadcrumbs as we're building that relationship to be able to migrate data from one version from other versions of hydrography data sets up to 3D-HP and main stems. Next slide, please. Okay, and so this is my last slide. There's a couple products that we have done or anticipate releasing. We're just, as of September 30th, winding down the first operational year of 3D-HP, so we're still getting things going here. We did manage to publish the final versions of the NHD and the NHD Plus HR last fiscal year. Both of those data products will remain available for the foreseeable future. They're out there on the online, not going anywhere. HydroAd for NHD will be available at least until October 2025. There are some software, again, obsolescence issues there that we may run up against, but we're good until October 2025. We are expecting, and Kim may talk about this in a minute or two, a final WBD release in November of this year. And we expect our first static 3D-HP release, the fiscal year 2024 sort of cumulative version, to come out about December 2024. So we'll wrap up all the things that we've added, both geometric features and attribution, bundle that up and have that out December-ish. We're starting quarterly service updates this year. Again, that'll be both geometry updates and any attribution updates that we can generate. We expect to have the first true elevation-derived hydrography data coming in from contract, getting published in January, and this will be with z-values and catchments associated with each of the new features. And then HydroRad 3D point addressing, also expecting that to be released in January. Those of you that have used HydroRad for NHD in the ArcGIS Online version, many of you with larger data sets have expressed some frustration with that. We have been working on building that on a different processor technology, and at least in internal demos, we're running about 100 times faster than we were running on ArcGIS Online. So rather than like 5,000 points an hour, like 500. Yeah, well, never mind the numbers. It's 100 times faster is the point. And so that makes migrating millions of observations that might have been tied to other data sets much more viable. Once we get the point addressing, sort of the basic thing out, then we expect to have batch points, lines, and batch lines following relatively quickly thereafter. And I think that is the last of my slides. And so with that, I'll pass it along, or pass it back to Karen. Karen?
Or I could pick it up. This is Silvia.
Or we can pass it to Sylvia.
Sorry about that.
I apologize. We
Not
didn't
mute.
rehearse this, so it's a little on the fly here.
Yeah,
All
next is Sylvia.
Okay, we'll go to Sylvia then. Okay.
And I'll just put my camera on for a minute because I also want to save bandwidth, but just wanted to say hello. Yeah, so I'm going to talk about the 3D-HP data model a little bit more in depth, just so that you understand what's part of the 3D-HP model. I think sometimes people get a little bit confused about, the source data that goes into it, and, we're getting that from two different places, and then what actually 3D-HP is. So I did want to just cover that a little bit. The next slide. And some of this might be a little repetitive from Steve's, but just wanted to stress a few things. Really, the data model is designed to be consistent in the coding and density, allow us to update it more easily. It's simplified. It supports the hydrologic applications and cartography, and it has a really strong 3D component to it. That's really key to the integration of our data sets or our data programs. The 3-depth elevation data and the 3D-HP exist together, and that's really key to, making sure that we have nationwide coverage for both of those that work together. Also, what Steve was just touching on, the high features OGC data model. Our data model is based on that. We want it to be open and compatible with other countries and resources that are using those data model. It is a conceptual data model, so ours has been operationalized, so it doesn't look exactly like what high features looks like, but it's still based on those same concepts and open data sources. So We also, a very important component, have that unique identifier for the streams that are based on that complete river system as opposed to just a segment within a river. So from the outlet to the confluence. Okay. Next slide. So I'll talk about these three parts of 3DHP. First, the inputs. Okay. Next slide. Yep. So NHD. So there are two data sources, as we've mentioned. The 3DHP was first populated with just the NHD high-res data. And again, we imported 95% of the features, but lumped them more or less into 10% of the feature types that we had in NHD. So instead of, again, the 20 different kinds of pipelines, we have one pipeline feature, etc. So we consolidated the feature types and we crosswalked those 107 different feature types into these 7 flow line feature types, 11 point feature types, and 4 water body feature types. You can see those here. We also have, I'll mention the data model online. I do have a link at my last slide, which shows you where you can grab the data model and take a look at it. But we also have the crosswalk tables as part of that documentation. So you can see what NHD feature becomes what 3DHP feature type. Okay. Next. Next slide, please. There we go. The other, obviously, what we're updating the NHD line work with is our EDH data, our elevation-derived hydrography data. And this is almost out of date. We're about to publish a new version of the specification by the end of the year. Right now it's out for review. We are consolidating the 2 different specifications, one which was described the data model and one that described each feature type in detail. They're all going to be in one document now to make it a little bit easier to reference. That will be released very soon. It also will have a new schema associated with it. We've tweaked a few of the codes. We've dropped a few of the feature types, added a couple of feature types. So this is an ongoing project, and we're still developing the best way of capturing a lot of these features. As we move across the country, we find more and more interesting cases of hydrography that we have to capture, and so we are tweaking the data model a little bit as we find those. Okay. Next slide. So again, the EDH, our elevation-derived hydrography source, is built directly from our 3DEP elevation data. We built it so that it would be integrated with the elevation both horizontally and vertically. So here you see on the left an example of where every vertex is at or below the elevation surface flowing downstream. And on the right, you see that all the new features are within channels or within creases on the surface that would likely contain water. So one thing to keep in mind with the elevation-derived hydrography, it is based solely, the only required source for delineation of the features is the elevation data set. So we are relying on the elevation to tell us where water is. And as many of you know, just because there's a crease in the surface or a channel, it doesn't necessarily mean there's water, but it's more likely to be a place where water gathers or flows. So we are capturing it based on those characteristics. Okay, next slide. So this is just an example of the density improvements. On the left, the NHD high res. On the right, the elevation drive hydrography. Next slide. And this is an example of the types of features that we've added to the data model, as well as the accuracy, an example of improved accuracy. You can see we now have breaching features because LiDAR, as many of you know, have a lot of things within the elevation surface that block the flow of water if you're trying to model it to go downstream. So we have added things like breaching features to allow the water to pass through roads in particular, but also other things in the terrain that stop the flow. And again, there are z-values on every vertex of the hydro network that's collected this way. So every single feature does have a z-value that matches within our threshold the elevation surface. Okay. Next slide. And this is just an example of one feature, and you can see that there is a downstream monotonic direction on every vertex. So it's going from upstream at 174.19 down to 170.9. Everything flowing downstream, every single vertex has an X, Y, and Z. Okay. Next slide. Okay. And the 3DHP core is the next part that I'll talk about. This is kind of where all the data that we input, both the NHD initially had some of the things that I'm going to talk about assigned to it within the core data model, but primarily the EDH gets ingested into the core data model and has a lot of the attribution and derivatives created here. I am making a distinction between the NHD source and the EDH source because they are treated a little bit differently as far as the types of derivatives that we assign. Okay, next slide. So all features do have, the data model associated with it and the schema associated with it. So we all have flow lines, water bodies, hydrolocations, catchments, and soon to have drainage areas part of the data model. So all of these get assigned to every feature. So NHD or elevation drive hydrography all have this structure assigned to it. Okay, next slide. All of them have the main stem identifier assigned to it. So again, that main stem identifier is really key to how we're identifying features, how we're tracking them across different data sets, how we're creating new data set or new features, and keeping track of those. The main stem identifier is that persistent identifier that you have heard about a lot already, and I'll say it again a few more times, but it really does provide that basis for how we're going to be tying things to the network and how we're going to be creating that link to other data sets. That last bullet there being scale independent is really an important part of this. So, the Missouri River, for instance, has one main stem ID at the 500K, 24K, and now at the elevation drive hydrography ingest level, it's going to have the same main stem identifier. So each of those will point to that same river. All right, next slide. So again, just to reinforce this, since it is so important, these main stem identifiers, we do have the individual identifiers on the small segments, but each one of those also has that main stem identifier that defines that entire river as well. So we have that the two identifiers are the main stem identifier and the ID3DHP identifier. The ID3DHP, I just will say, is not a permanent identifier for a segment, because as we update features. We might have to change that individual identifier with future ingestion, but that main stem identifier will always be consistent. Okay, next slide. The flow network derivatives are going to be a set of features that are derived for every ingested data set using the elevation-derived hydrography source. So if people are, I saw a number of people were familiar with NHD+. They're going to look a lot like NHD+. However, they are a little bit different. Some were dropped from NHD+, some were redundant from NHD+, so we didn't feel like we needed to calculate those here. But some of the key ones that allow us to do things like network navigation, upstream aggregation and calculations, those stream order, which people find very important, those are all present in our flow network derivative table. So these probably look familiar again to the NHD+ folks out there. Okay, next slide. The other thing that we haven't really touched on are our elevation derivatives. Since this is being derived from our 3-depth data, it's really important for us to keep track of the elevation source. And anything that we create from that elevation source has to be able to be tied back to it. We have decided to go with a national projection for our data, and that's Albers CONUS EPSIG 6350 in the lower 48. We have an Alaska standardized coordinate system, and all the islands have their own coordinate system as well. But that allows us to have a seamless elevation data source for the data. And that way, when we enforce the line work into the elevation, that also is going to be seamless between project areas. So currently our elevation derivatives that we're planning on making public are the source elevation and a hydro-enforced version of the elevation surface as well. And that would contain the stream network that's with the Z values assigned to each vertex overlaid on the elevation surface, with all breaches enforced, so no more blockages in the flow, so that it's a continuous network through where the stream network is within the elevation surface. Hopefully that made sense the way I said that. And happy to answer questions on that if you have them. Okay, next slide. Catchments are also really key. Again, if you're familiar with NHD+, if you want to tie information that's off network to a stream network, just based on the overland flow to a network, catchments are a really handy way of doing that, or summarizing land cover characteristics or soil characteristics that are, upstream of a point on a stream. So we are creating catchments for our data. It'll be similarly defined the way that we've done catchments in the past, in that it'll be confluence to confluence. We are going to have a few other rules thrown in there, but I won't go into them because it's kind of into the weeds. But basically, it's confluence to confluence. There is one thing that we are adding, and that's a headwater catchment. So every headwater point at the end of the network will also have a catchment that indicates where the headwaters are flowing to the network. All right, next slide. And then the user views, I'll just go through this quickly because Steve already did a good job of describing this, but next slide. We have our web services right now as a WMS and hopefully soon as a WFS. We've been having some problems DOI wide, I guess, of serving it as a WFS, but hopefully we'll be getting that up and available soon. We've got all of the data primarily now. It's still a reflection of the NHD line work. We don't have a lot of data in there yet that's elevation derived hydrography. We're still developing tools for ingestion, but we hope to this year really ramp up the ingestion of that EDH data, so you'll be able to see more of that reflected in the data. Okay, next slide. And again, I won't spend much time on Internet of Water and GeoConnects because Steve covered that really well. So next slide. Again, this is just an example of the main STEM ID being a component and an actual link within the data set itself. So you can click on that and go straight to GeoConnects to get the representation of the stream river. And then one thing that is exciting, next slide. The collaboration we have with the GeoConnects folks, they're starting to add stream gauge information right on that link so that you can start to get, as soon as you access that main stem, you can access information like all of the stream gauge information that's tied to that river. And what we'd love to be able to see are not just stream gauges, but other information that has been cataloged and addressed to the main stems, so you can go to this page and find that information readily. Next slide. And this is, again, just an example of the downloadable products that we'll be serving. We'll have that yearly snapshot and we'll have the quarterly updates. But it will be the hydrography features, so the vectors. It'll be the stream raster with Z values, either as part of the hydroforced elevation data or as a separate product. We are still kind of mulling that one over. The source elevation data and catchments as downloadables by the end of this year. Okay, next slide. And this is just an example of the links to the various documentation that we have out there now. So feel free to take a look at all of the specifications that we have. We have a poster, which is kind of a nice way to look at all the tables together. We do have the crosswalk tables, both for NHD and EDH, so you can see what features are going to what 3DHP features, and the link to the web service as well. And I think that's my last slide. So I'm gonna, I believe,
Perfect.
Kim. Yes.
Thank you. Thank you. So yeah, we've heard a lot so far about the hydrography portion of the, what's been going on with our legacy historic data sets and what we're doing in the future. I'm going to briefly touch on what's going on with the watershed boundary data set and what we're doing with that. So just a brief history. The WBD is our comprehensive national hydrologic unit data set for all of the United States and its territories. It's a nested system so that, smaller units, smaller numbers represent our largest, extent, our regions. And then as you subdivide those regions into smaller units, our coding structure is such that the numbers get bigger and our units get smaller. And it is complete, as I mentioned, for the country to the 12-digit. We do have in some areas some 14 and 16 digits. They were kind of developed on a case-by-case basis, kind of after the fact, but they are there right now in certain areas. Next slide, please. So like with any data set, there's a planning phase before this, but there's a development phase, a maintenance phase, and then kind of this maturation. What do you do when you get to a point where the data is mature and, maybe you need to look into the future with the data? So just a really brief history, this has been going on for 20 plus, 30 plus years. It was developed as a partnership, pretty much on a state-by-state basis, but using a set of standards that were published to kind of help align data across the nation. That development phase really was the 10 and 12 digits. The 8 digits and higher were developed many years before that on paper maps and then digitized into the USGS 250K HUC data set. And so we had those to start with, but that next step was to develop those 10 and 12 digit smaller subdivisions. And so the data was developed, it was completed in 2012. And we basically, as a state completed their data set, they basically went automatically into a maintenance phase. So even between the 1990s and 2012, we did have some states that were updating their data right away, right? Really, the maintenance started around 2008 until just recently. Our national team has been continuing to make improvements. Our states were allowed to make improvements up until last year. And so, we've really looked at improvements to the data, but it hasn't been consistent across the country like everything else. But just to give you some examples of things that we've done, we completely replumbed the Great Lakes region. And we added in worked with our Canadian partners to add in cross-border hydrologic units down to the 12-digit. We worked with our partners in Mexico to add in, the 8-digit cross-border units down to the 12-digit. We decided that, hey, we really need to know everything that's flowing into the United States. So we went back and we added in, all the contributing areas in Canada, all the contributing areas in Mexico that contributed flow to the United States. So that's kind of things that the national team did, was those big kind of projects that were needed to help flush out the data set to make it more robust. States were doing updates along with that. And a lot of the state updates were things like fixing potential issues as you get better source information, going in and updating with LIDAR and IFSAR data, adding 14 digits in certain areas and things like that. So, a 30-year program, we've kind of, it's a robust data set. We feel that it's in a pretty good place. And so now we're looking with the whole 3D hydrography program, where do we need to go now? And that's really what we're focusing on for the future. Next slide, please. So I like to show this slide because it always amazes me. The minimum requirement for the WBD was the 24K DRGs. We did a kind of a poll because there's a line source field in our data that tells us what every line was supposed to be based off of, right? And we calculated 85 different unique sources were used to create the WBD over time or make improvements to it. And those sources were used in a combination of like 800 unique combinations. So you could have multiple sources being used to represent the one line. So you could have, the NHD and the DRG24 and some imagery. Somebody, it was just unclear. So somebody added some imagery in to look at it. Or maybe it was part of it was field verified. So it's just there, this just shows how many different sources could have been potentially used to help inform where the WBD came for and the need for those improvements that we have done over time. Next slide. As has been mentioned already, I'm going to reiterate it, the WBD was created a specific way. And then we had these other hydrography products that were being used for modeling applications and other applications, the NHD plus HR catchments. And, most of the times they aligned, but not always, just because of, different vintages in the source data. We have different rules that were used to generate them. And so there was this misalignment between kind of our reporting administrative WBD type use and some of the modeling type uses within NHD plus HR and NHD plus medium res as well. So moving into 3DHP, we're really looking at bringing the hydrography, the elevation, and the drainage areas together so that they're all from that same source and they can be used collaboratively, right? And so, as mentioned, we're looking at methods to do this by deriving our drainage areas, which are going to replace the WBD through our catchments that are being derived on the ingest process of the EDH into the 3DHP. Next slide, please. While all of this has been going on, kind of the thinking about that process and building that, our national team has been working on some of the kind of final little data cleanup things that we thought we needed to do to create a final snapshot. And there's a reason final is in quotes. And then I'll mention that just briefly in a minute. But we've had some things that we thought we needed to review to help prepare us for the next step. So we took a close look at what we were calling closed basins and did our best working with our state partners to see, is it really a closed basin? Is it not? Is it just closed in certain conditions? What do we need to call those in the WBD? We added our GNIS IDs that were used for the names of the hydrologic units. So we pulled those IDs from the GNIS database so that we can tie the names that the hydrologic units were named after back to our official GNIS database. We implemented all the user markups. So there was an application out there where if somebody found an error in the data, they could add a markup. I will say we implemented all approved markups. There were some that just didn't make sense for us to implement at this time because we knew we were going to get better base information. And so we held those off for 3DHP. Working with big data sets, you always have these topology issues that creep in. So the graphic on the bottom kind of shows it. There's like all these teeny little gaps in the data. We went in and we did our best to clean up all the kind of odd topology issues. And then we did add the Yukon Canadian contributing areas. That was the last outstanding Canadian areas that we needed to add. So we wrapped all of that up and we're looking at, like Steve mentioned, publishing a final snapshot. With that being said, next slide, please. There is an initiative in Alaska to build EDH. And as they were, building the EDH, we were realizing that there were some pretty major changes to the hydrography that were going to result in some pretty large changes to the WBD. And so we, right now, at least are planning on continuing to improve the WBD with the elevation-derived hydrography and maybe doing like a yearly update to the WBD data just for Alaska because of these pretty drastic changes. I mean, we're seeing things like whole 10 digits, like moving from one area, like one HUC8 to another, just because of the scale, the source. The original source was 1 to 63, 360 topographic maps. And now we have 5-meter IFSAR data across the state of Alaska. And so just because of that difference, we're seeing some pretty drastic changes. I just have an example here. These are 10 digits for one HUC8. And like the headwater 4 units at the top of the graphics, they're pretty stinking close. But as you get down to the outlets, the on the right, the updated, those kind of orangey polygons, they're like totally different from what we currently had in the WBD. And so any change at the 10 digit just increases at the 12 digit, and we have codes that have to be retired and new codes assigned, and it's just really complicated. So we decided that it would probably make sense to try to continue that, at least for now. We'll see how things go in the future, if that works or not. So just so you're aware, maybe there might be an update for Alaska in the future. Next slide. Oh, actually, one more click, and it just kind of shows a comparison, maybe, if the automation works. There we go. So the thick brown lines are kind of the overlaid, and you can kind of see the changes down in the south, where one whole HUC 10 just goes away, and we have to assign new HUC 10 codes. So it's very interesting in Alaska with the new data. Next slide, please. So the plan is, as mentioned, we will load a version of WBD into the 3DHP as a placeholder for our new drainage areas. We do have a few slight differences in that version of the WBD that are pretty large. We tried really hard to not make really drastic changes to the WBD if we could avoid it, because of how people tie things to the HUC codes. We feel that this is a great opportunity for us to fix known issues in the database at high levels, like at the region level or the 4-digit level that we've known about, but we've held off on implementing because of the cascading effect with HUC codes. If you change a 4-digit, you have to change every 6, every 8, every 10, every 12. And so we just didn't want to do that. This is a great opportunity for us to make these fixes, cut the ties, and have that legacy WBD version and our 3DHP version of the data. The graphic on the right just kind of shows this is the outlet of the Mississippi River. We had areas lumped in the 4-digit that represents the outlet of the Mississippi, actually at the 2-digit that represents the outlet of the Mississippi, that didn't even contribute to the Mississippi. It did not make sense to include those in with the Mississippi Delta unit. And so we're looking at those and deciding how what should those be coded? Where should they be lumped with? What makes sense, right? And then we are going to replace the existing WBD with the 3DHP generated, roll those up into our hydrologic units, our drainage areas, so that everything is in alignment as new EDH data is loaded into the 3DHP data model, and those catchments are built, and then we'll have a process in place to roll those up to the new model. Next slide, please. So this just kind of shows, on the far left, the current WBD for 1 HUC 12, what the catchments of some draft data that we got look like. And then, the rolled up drainage area, 3DHP drainage area on the far right. One more click, and I think I have everything overlaying. So, yep. So you can see that we imagine that everything's going to be, for the most part in alignment. There are going to be those odd areas where there's a little bit of a difference. You can see at the outlet, there's a little bit of a difference between the catchment in the 3DHP drainage area and the original WBD. A lot of that had to do with the level of the source data, the development of roads and anthropogenic features. And so we will have slight differences, but, across the state, we figure we can, get something pretty close. There will be differences though. So I just want to make that people aware of that as we look at the data, some of the rules might be slightly different between the legacy standards for WBD and 3DHP. We want to do what makes sense for people. And so we're fleshing that out over the next year and planning on, a process to kind of align these data sets a little better into, the 3DHP drainage areas. And that is it for me, I believe.
Thanks, Kim. So I am gonna finish up with kind of going back to the beginning of this major goal that we have to remap hydrography for the entire United States, and looking kind of at a slightly different view of the data life cycle. We've shown a couple different versions, but this one includes the planning and data acquisition piece of this, which is what I am the lead of. Next slide. So as Steve mentioned earlier, again, we have the goal to completely remap the nation's hydrography for the first time since the original topographic mapping program several decades ago. And we're approaching this with a completely different paradigm to how we collect and maintain these data. As mentioned previously, we used a stewardship model that worked quite well. It allowed stewards to kind of reach up into our database and make changes to those data. We're moving towards a partnership model for data acquisition that really is built on working with the broad community to collect data through an organized partnership process, leveraging the capacity and expertise of the private sector to do most of the work, and then providing specifications that are sort of the bar to which we need to meet. That ultimately will avoid some of the long-term changing and wiggling of data lines through data maintenance that we used to go through, and that resulted in pretty inconsistent data in the NHD. Next slide. So as I mentioned, we are largely planning on leveraging the private sector to do a lot of the work, not only for expertise, but also for the capacity available in the private sector. We are largely using the USGS Geospatial Products and Services Contracts, or GPSC, which is a multiple award acquisition vehicle where the firms on the GPSC contract have been selected for their qualifications to provide the professional services needed. And that includes collecting LiDAR data for 3DEP, as well as collecting hydrography data derived from that 3DEP data for 3DHP. And then, as we've mentioned, but I'll say it again because it bears repeating, that we then perform validation on those data to ensure that it conforms to the specifications that we've set. We'll also have an option through the partnership process for state and local partners to manage their own acquisition contracts through a financial assistance award or a cooperative agreement. So USGS cost share through a cooperative agreement. Next slide. So this is kind of a big view of the data acquisition process, again, sort of built on partnerships, looking at it from sort of the federal working group side, as well as the state, local, tribal, academic, private sector side, that both come together to create sort of an annual data acquisition plan. And this process works the same way for both 3DEP and for 3DHP. So we're consistent in the way that we work on partnerships and award contracts. So on one side, we have federal working groups that I'll go into more detail about, but the working groups work together on acquisition planning, and we can partner directly with our federal working group members or other federal agencies, enter into interagency agreements, and then we can actually use those funds as needed as matching funds on DCA applications. DCA is our data collaboration announcement, or for direct data acquisition. And on the other side, as I mentioned, the data collaboration announcement is a process that we use to collaborate with non-federal partners on projects and data acquisition. Next slide. So we use this mechanism as a way to make sure that we use sort of a fair and equitable process to select partnerships for data acquisition, again, both for 3DEP and for 3D HP. So the process is that partners submit a project proposal, and that is reviewed by a team of reviewers and looked at for certain qualities, such as how much cost share is the partner bringing to us? Is this for collection of new data or recollection in the case of 3DEP in particular? And then 3DHP matching funds are brought to cover the additional remaining costs of the data acquisition. And then, as I mentioned earlier, we can partner directly with federal agencies outside of the DCA. Next slide. So, of course, this takes a lot of collaboration, so both on the state and the federal side. On the state side, we do collaborate directly with the National States Geographic Information Council that allows us to engage directly with state geographic information officers and key stakeholders. And then, as Karen mentioned earlier in the presentation, the National Geospatial Program has a network of national map liaisons who help us lead outreach and coordination for 3DHP in their respective states and regions, both at the, again, local, tribal, and regional federal office level. And then we kind of keep all these key stakeholders informed of what we're doing so we can align our data acquisition goals between our federal and non-federal partners. Next slide. So, and as I mentioned earlier, we also have federal coordination that's managed through the 3DHP working group. One of the primary goals of the working group is to have the member agencies working towards a common goal to improve the currency and accuracy of our national hydrography mapping through the 3DHP and support for data acquisition and the technologies for 3DHP. So we coordinate with our member agencies quite a bit to develop and execute acquisition strategies to understand where their mapping priorities are and where there may be available funding to support data acquisition to support national and agency-specific goals for 3DHP. And then we also have a technical subgroup that Silvia manages, which is a venue for sort of deeper technical discussions around 3DHP and where we're going with 3DHP. And this is a part of a joint 3D national topography model governance in support of our vision for a 3D nation, meaning a continuous elevation surface and integrated hydrography data to create a 3D national topography model. Next slide. So I think Steve may have mentioned, but it might have gone by a little bit quickly, that federal fiscal year 24, the fiscal year that just ended, was the first operational year for 3DHP. But data acquisition in Alaska has been ongoing since some pilot projects that we ran in 2019. And the funding largely through USGS National Alaska Map Modernization funding, but we also have partnered in Alaska with Fish and Wildlife Service and BLM. And since 2019, we have, there were about 314,000 square miles available, ready to be ingested or in progress through the end of last fiscal year. In this fiscal year, we added another 98,000 square miles to that collection, and we're over 70% complete for Alaska, complete or in progress with data. CONUS, Islands and Territories, really we picked at the edges a little bit with data acquisition, piloting in a few areas over the years that got us to about 60,000 square miles of data available or in progress through FY23. And in FY24, again, our first full year of partnering data acquisition for 3DHP is the first year of a data collaboration announcement for 3DHP. We collected over 115,000 or contracted for over 115,000 square miles in FY24. And that brings us to about 16.4% of the nation, Alaska, CONUS, islands, and territories as of October 1, 2024. I don't have the figures here, but the power of partnerships is kind of clear here in that for CONUS, the total cost of the contracting for data acquisition in FY24 was about $14 million. And about 66% of that was funded by partners, not USGS. About $7 million was state, local, tribal, and other partners bringing their partnership money to bear to start us off to complete our goal of remapping the nation.
We thank the presenters and the hosts of the webinar. You can find more information about the 3D Hydrography Program at usgs.gov/3DHP and about the National Fish Habitat Partnership at fishhabitat.org.
The letters USGS and word Signs for a Changing World appear in white, then fade to black.